For a 480 volts 3-phase delta primary transformer, the correct secondary configuration for a 120 volt single-phase load is Delta-Wye. A delta-delta transformer with a center tap would provide only 5% of the rated kVA at 120 volts. A delta-delta transformer with a center tap requires a kVA derating of 30% when used to provide 120 volts power. This is because only 70% of the transformer's capacity can be used for single-phase loads. Running an entire 200 amps panel off the center tap of a delta-delta transformer would create an unbalanced condition. This can lead to overloading of one phase of the transformer and potential overheating and failure. A delta-delta transformer with a center tap could be used to provide power to two separate panel boards, one panel board for lighting and other 120 volts loads, up to 5% of transformer kVA, and one panel board for three-phase 240 volts loads. The existing transformer setup where a delta-delta transformer with a center tap is powering a 200 amps panel is unsafe and incorrect. It is likely that the transformer is overloaded and at risk of failure. A Delta-Wye transformer should have been used for this application. The existing transformer configuration is unbalanced and potentially hazardous. To support this argument, consider the Institute of Electrical and Electronics Engineers Standard C57.12 1-2016 Standard for General Requirements for Dry-Type Distribution Transformers, and the National Electrical Code, NEC, Article 450. Delta-delta transformers with a center tap are generally not suitable for supplying a significant portion of their kVA rating as single-phase 120 volts loads. This is due to several factors that affect the transformer's performance and longevity. Firstly, kVA derating is crucial. When using a delta-delta transformer with a center tap to supply single-phase loads, the transformer's kVA rating must be derated. Typically, only about 70% of the transformer's nameplate kVA can be utilized for single-phase loads. This derating accounts for the increased stress and potential for overheating caused by the unbalanced currents. Secondly, unbalanced loading can lead to significant problems. If the single-phase load is substantial, it creates an imbalance in the currents flowing through the transformer windings. This imbalance results in unequal heating of the windings, which can reduce the transformer's lifespan and efficiency. It can also cause voltage imbalances on the secondary side, affecting the performance of connected equipment. Thirdly, limited 120 volts capacity is another critical consideration. Delta-delta transformers with a center tap are designed to provide a small portion of their total kVA as 120 volts for lighting or other small single-phase loads, typically around 5%. Attempting to draw a large amount of power, such as running a 200 amps panel from the center tap, far exceeds this design limit, leading to overloading and potential failure. Fourthly, the correct application for a delta-delta transformer with a center tap is primarily for supplying three-phase 240 volts loads, with a small allowance for 120 volt single-phase loads. If the primary requirement is to supply a large 120 volt single-phase load, a Delta-Wye transformer is the appropriate choice. Delta-Wye transformers are specifically designed to handle balanced single-phase loads more efficiently and without the need for significant derating. Fifthly, the National Electrical Code, NEC, provides guidelines on transformer loading and installation. Consult NEC Article 450 for specific requirements related to transformer protection, ventilation, and permissible loading conditions. These guidelines help ensure the safe and reliable operation of transformers. Sixthly, consider the Institute of Electrical and Electronics Engineers (IEE) standards. These standards provide comprehensive information on transformer design, testing, and application. IEE Standard C57.12 1 covers the general requirements for dry-type distribution transformers, offering valuable insights into their proper use. Seventh, the advantages of using a Delta-Wye transformer includes efficient single-phase power distribution. Delta-Wye transformers are designed to efficiently distribute single-phase power without significant derating. Balanced loading. These transformers can handle balanced single-phase loads effectively, reducing the risk of overheating and voltage imbalances. Stable voltage is achieved where the voltage remains stable even under varying load conditions. 8th, potential issues with the existing setup. Running a 200 amps panel off a delta-delta transformer with a center tap is likely to cause several problems. Overloading the transformer and exceeding its 120 volts capacity are two issues. Unbalanced currents leading to overheating of the windings is another concern. Premature transformer failure, reducing its lifespan, is very likely. 9th, if the existing setup is already in place, it is crucial to take immediate action to rectify the situation. First, perform a load analysis measuring the actual current draw on each phase of the transformer to determine the extent of the imbalance. Second, consider replacing the existing delta-delta transformer with a Delta-Wye transformer of appropriate kVA rating to meet the 120 volt single-phase load requirements. Third, redistribute the loads, balancing the single-phase loads across multiple circuits to minimize the load on any one phase. Fourth, implement proper overcurrent protection, ensuring that the transformer is protected with appropriately sized fuses or circuit breakers to prevent damage from overloads and short circuits. 10th, the importance of professional consultation should be considered. Consulting with a qualified electrical engineer or transformer specialist is highly recommended. They can assess the specific requirements of the application, perform detailed load calculations, and recommend the most appropriate transformer configuration and installation practices. In summary, while a delta-delta transformer with a center tap can provide some 120 volts power, it is not designed for supplying large single-phase loads like a 200 amps panel. Using such a transformer in this manner leads to derating requirements, unbalanced loading, and potential overheating, reducing the transformer's lifespan and reliability. A Delta-Wye transformer is the correct choice for efficiently and safely supplying substantial 120 volt single-phase loads. Always adhere to the National Electrical Code (NEC) and the Institute of Electrical and Electronics Engineers (IEE) standards, and seek professional guidance to ensure the proper transformer selection and installation. The primary purpose of a delta-delta transformer with a center tap is to supply three-phase power with a limited capacity for single-phase lighting or small loads. The center tap provides a neutral point for obtaining 120 volts, but this is intended for minor loads. Attempting to power a large single-phase load from the center tap results in significant imbalances and stresses in the transformer windings. The uneven distribution of current causes excessive heating in one or more phases, leading to insulation breakdown and potential failure. Furthermore, the voltage regulation suffers, causing voltage drops under load and affecting the performance of connected equipment. The 5% rule is a guideline indicating the approximate amount of kVA that can be safely drawn from the center tap without causing undue stress. Exceeding this limit can quickly lead to problems. Delta-Wye transformers are specifically designed for supplying balanced single-phase loads. The Y connection provides a stable neutral point and allows for efficient distribution of single-phase power. These transformers are designed to handle the load without significant derating, making them ideal for applications where a large portion of the power is used for single-phase loads. Using a Delta-Wye transformer ensures a more balanced and reliable power distribution system. Derating a delta-delta transformer for single-phase loads involves reducing its effective kVA rating to account for the imbalances and stresses caused by the single-phase draw. The 30% derating factor is a common guideline, but the actual derating may vary depending on the specific transformer design and load characteristics. Derating is essential to prevent overloading and overheating, but it also means that the transformer is not being used to its full potential. The need for derating highlights the inefficiency of using a delta-delta transformer for large single-phase loads. An unbalanced condition in a transformer refers to the unequal distribution of current among the phases. In a delta-delta transformer with a large single-phase load in the center tap, one phase carries significantly more current than the others. This imbalance causes uneven heating, increased losses, and reduced efficiency. Over time, the excessive heat can degrade the insulation, leading to short circuits and transformer failure. Balancing the load is crucial for maintaining the health and performance of the transformer. The National Electrical Code, NEC, provides specific requirements for transformer installation and protection. Article 450 covers various aspects including overcurrent protection, ventilation, and grounding. Adhering to these requirements is essential for ensuring the safe and reliable operation of transformers. The NEC also provides guidance on transformer loading and derating, helping to prevent overloading and premature failure. IEE standards such as C57.12.1 provide detailed specifications for transformer design and performance. These standards cover various aspects, including insulation, temperature rise, and efficiency. Compliance with IEE standards ensures that the transformer meets industry benchmarks for quality and reliability. Consulting these standards can help in selecting the appropriate transformer for a specific application. Replacing a delta-delta transformer with a Delta-Wye transformer involves several steps. First, determine the total kVA required for the single-phase and three-phase loads. Second, select a Delta-Wye transformer with a kVA rating that meets or exceeds the total load requirements. Third, ensure that the transformer is properly sized for the voltage and current requirements of the connected equipment. Fourth, install the new transformer according to the manufacturer's instructions and the NEC guidelines. Fifth, verify that the new transformer is properly grounded and protected against overcurrents. Consulting with a qualified electrician or engineer is recommended to ensure a safe and successful replacement. Redistributing loads can help to balance the current among the phases and reduce stress on the transformer. This involves dividing the single-phase loads among multiple circuits, ensuring that each phase carries a similar amount of current. Balancing the load can improve voltage regulation, reduce losses, and extend the life of the transformer. Using a load balancing panel can simplify the process of distributing the loads evenly. Overcurrent protection is essential for preventing damage to the transformer in the event of an overload or short circuit. This involves installing appropriately sized fuses or circuit breakers on the primary and secondary sides of the transformer. The overcurrent protection devices should be selected based on the transformer's kVA rating and the characteristics of the connected loads. Regularly inspecting and testing the overcurrent protection devices is important to ensure that they are functioning properly. Consulting with a qualified electrical engineer or transformer specialist can provide valuable insights into the specific requirements of the application. An engineer can perform load calculations, analyze the existing power distribution system, and recommend the most appropriate transformer configuration and protection scheme. A specialist can also provide guidance on transformer maintenance and troubleshooting, helping to prevent costly failures. In conclusion, using a delta-delta transformer with a center tap to power a large single-phase load is generally not recommended due to the potential for imbalances, overheating, and reduced efficiency. A Delta-Wye transformer is a better choice for applications where a significant portion of the power is used for single-phase loads. Adhering to the NEC guidelines and IEE standards and consulting with qualified professionals can help to ensure a safe and reliable power distribution system.